Mrs. McBride here. What we're doing today is some demonstrations using Newton's first law. Remember, Newton's first law says an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an outside force. The way today is going to work is that you're going to make a prediction in terms of what you think is going to happen. Don't worry about predicting right. This is just getting credit for this assignment, not necessarily keeping score. So the first demonstration I'm going to do for you is I'm going to put an index card on top of this cup, and I'm going to put a magnet on top of here. All right. I'm first going to pull as slow as humanly possible, and I want you to make a prediction in terms of what you think is going to happen. All right, here I go. This is the world's most exciting experiment. All right, so what you saw is that it just continued to stay on the index card. All right, the second experiment is now I'm going to pull as fast as humanly possible. I want you to make a prediction in terms of what you think is going to happen. All right, here we go. So what happened is that this magnet was an object at rest that stayed at rest, and since it was here, when I pulled as fast as possible, it fell right in here. So an object at rest stays at rest. All right, now let's kick it up a notch here. I've got this hoop, and on top of the hoop, I'm going to place a penny. And what I'm going to do is I'm going to pull on the hoop as fast as humanly possible, and I want you to make a prediction in terms of what's going to happen. Here we go. Again, Newton's first law says an object at rest stays at rest. Excellent camera work, Mr. McBride. All right. Next thing I want to take a look at is I have a measuring cup. On top of the measuring cup, I'm going to put a paper plate. On top of this is a toilet paper roll. And on top of that is an apple. I'm going to make sure I've sort of lined this up correctly. All right. And I'm going to pull the paper plate as fast as humanly possible. So I want you to make a prediction in terms of what you think is going to happen. Here we go. All right, now you might be saying to yourself, why did that happen? All of these objects, well, except the plate was an object in motion that stayed in motion, okay? But both the apple and the toilet paper tube were objects at rest. Why didn't the toilet paper tube stay at rest? Well, because this has less inertia than the apple. Remember, inertia is the natural tendency to stay at rest or stay at motion. And since this doesn't weigh that much or doesn't have a lot of mass, this flew off, whereas this fell right down. Speaking of inertia, have you ever seen this trick before? I call it a trick because sometimes people think that science is magic. All right, so here's my tablecloth. And on top of the tablecloth, you've probably seen some people put lots of glass objects, but we're not going to do that today. The first thing I want to do is start with a paper cup. And what I'm going to do is use my magician skills here and pull as fast as humanly possible, okay? So make a prediction in terms of what you think is going to happen. Ready? Been practicing this all day. Here we go. That was an object at rest that all of a sudden started in motion. What do you think happened there? Well, the problem is that the paper cup does not have a lot of inertia. So what we can do is let's try this again with something that does have a lot of inertia. All right, now let's make a prediction in terms of what do you think is going to happen when I pull the tablecloth out now. Here we go. So what you saw is that the book was an object at rest that stayed at rest. And since it has more inertia, it was more likely to stay at rest. One last time, because you really just can't get enough of this kind of stuff, is if I add even more inertia, okay, what do you think will happen now? All right, here we go. let's take 2 on that one. All right, take 2, here we go. There we go. All right, so again, it was more likely to stay at rest. It was so likely to stay at rest that I couldn't even pull the tablecloth out. All right. Here's one of my favorite demonstrations with one of my favorite drinks, as you know. I've got 2 empty bottles, and I'm gonna put a $10 bill here in between these bottles. And normally, if we were in school, I would tell you, if you can get the $10 bill out from in between these bottles, you get to keep it. My cat is now playing with the cup. It fell on the floor. All right, so first thing we're gonna do this is with empty bottles. I've been practicing all day. So first, make a prediction in terms of what you think is going to happen here. All right, here we go. That's a good thing I've been practicing all day, because this is pretty tough when the bottles are empty. Let's try again. It's a good thing I've been practicing. All right, what normally happens is that this is really hard to do when you've got 2 empty bottles because they don't have a lot of inertia. So what I was going to do is I was going to show you that this should be easier to do once you have 2 full bottles. Let's make sure these guys are lined up. And here we go. Again, because they have more inertia, they're more likely to stay in place. But so are the empty bottles, so sometimes physics just works for you. All right, last thing I wanted to show you is this. I have my car here, and it's set up to a weight that I'm going to hang over the edge here. But before I do that, I want to put a passenger on here. Thank you so much, Superdog, for volunteering for this experiment. All right, so there is Superdog. And I'm going to drop this over the side. And my question to you is, what do you think is going to happen? All right, on your mark, get set, go Superdog. I'm just doing great here today. Remember, we talked about this. You know what to do here. Okay. Take 2. Sometimes Superdog doesn't do what he's supposed to do on the first shot. So what I was hoping to show you and what happened on the second version is that Superdog was an object in motion that stayed in motion. And since there was no outside force, Superdog just went ahead and fell off the counter. So what we can do, and this is what we do a lot of times in real life, hopefully, is we're going to put a seat belt here on Superdog. Okay? So if we do this experiment again, now that Superdog is wearing his seat belt, hopefully the results will be a little bit better for him. All right. So again, wear your seat belt. It's very important so you don't end up falling off the counter like Superdog. Thanks for watching. Bye, friends.